In this video, you will learn about a book that is the best and simplest quantum field theory book ever written. Yes, I will also talk about the common difficulties people face when learning QFT and why this book makes the whole process much easier. If you have been struggling with complicated explanations or heavy math, this book will change the way you see QFT. It makes the subject intuitive, easy to follow, and surprisingly enjoyable, perfect for beginners and curious minds alike. My name is Shaunak and you're watching this video on my channel, Physics for Students. Well, before beginning and talking about this magical book, I would like to address this question. Is quantum field theory very difficult to learn? Which is a common notion among the students and those who are beginners. Well, what I can tell you is that the answer to this question depends actually on your objective. Is quantum field theory difficult to learn? It depends upon your objective. What I can tell you is that nothing is inherently difficult. What actually feels difficult to you is something that you don't know yet. Once you come to know, things are much easier. So the question, the objective is that why do you want to learn quantum field theory? Well, if I take the first objective can be, well, you want to get a basic overview of this theory. That can be objective one. The second is that you want to have a very strict and a rigorous mathematical understanding of this theory, objective number two. And third is that you have to have a kind of a intuitive as well as a mathematical understanding, objective number three. Now, depending upon these three objectives, the answer depends that whether it is difficult, rigorous, intuitive or easy. So as we go ahead and understand, we see that quantum field theory is definitely considered to be one of the crowning jewels of modern theoretical physics. However, as you can see, the equations are complicated because it actually combines three pillars of modern physics: quantum mechanics, special relativity, and certain areas of advanced mathematics. So all these diagrams that you see, the up quark, the down quark, the Feynman diagram, two electrons annihilating to become a photon, the quarks moving, etc., actually gives you the sense that quantum field theory is definitely beautiful, but it is not for the faint heart. That means you cannot think that quantum field theory, you will lie in a sofa, read a book and so on. So the objective of this video is to make this explanation and talk about a book, the problems which will make the learning quite easier. Now, the difficulty of quantum field theory in terms of learning is not at all a complicated math, which I have understood. So, why it is difficult? Because it combines a wide range of subjects. For example, one is quantum mechanics, which is the realm of the very small. Next, you also need to know about Einstein's special theory of relativity, which is, objects moving closer or nearer to the speed of light. And you also need to know the classical theory of field, which pervades the nature and is the realm of continuous fields. And there is a shift that particles are no more particles, but they continue to be treated as vibrations or quanta of fields. So from here you can understand that the QFT's difficulty is not on the math, but on the huge area of physics that you need to know and the expertise that you need to have. But I have a good news for you. The good news is that any good book eases out this process. It explains the mathematics and the physics in a very, very simpler manner. It helps you to build the intuition before diving it in the heavy mathematics. So what I can say you is that the secrets of mastering any complex subject, for example QFT, is not rushing into equation, but first understanding the concept of physics very clearly. So in subjects like QFT, selecting the right book is a very important factor. If you end up with a wrong book, you will waste a lot of time and energy in understanding the subject and you will never understand the subject. So that is the thing. So good books provide a proper structure. A good book bridges the gap between an intuitive and a mathematical understanding, and a wrong book, which is most dangerous, will lead to a lot of confusions. Now, when we talk about the book, there are a lot of books which are there in quantum field theory. But why selection of the book is very important. Now, as you go to the market or go to Amazon, etc., you see a huge amount, a myriad of books available in quantum field theory. Some of them are lectures, some of them are a huge amount of mathematics, some of them try to give you an intuitive understanding, and a lot of options which are available. And options makes things more complicated. Now, here in this earlier video, which you can find out on my channel Physics for Students, I have just discussed about these 3 books. Now, I'm just going to give you a quick understanding why these 3 books are important before we go and dive into the magical book that I'm talking about. First is that the Klauber's book, that is student-friendly quantum field theory. This is a book where Professor Klauber emphasizes on treating fields as operators. This might come as a direct analogy with the quantum mechanics that you have learned, but for some it becomes difficult. He also develops the algebra step by step, and there are a lot of deriving of the commutation, relation, propagators, etc. He promotes in this book from classical fields to operators, conjugate momenta, etc. And Klauber introduces a lot of propagators, which shows how fields propagate to interact. He also gives a very detailed derivation of both scalar and spinor fields. There are a huge amount of usage of heavy integrals, distribution, operator manuals, and physical intuition sometimes become very less, and it is more and more of formal mathematics. So from here, what we can understand is that Klauber's student-friendly quantum field theory is definitely a great asset, a great book, but it has a lot of heavy mathematics, and you need to have a very rigorous step-by-step understanding before you go in Klauber's book in order to understand quantum field theory. The next book that I talked about in the earlier video, and what I would like to emphasize here, is this book, Quantum Field Theory for the Gifted Amateur, one by Professor Tom Lancaster of Durham University and Stephen J. Blundell. Now, the book actually is much easier in terms of the approach because it starts with the quantum harmonic oscillator, which is a very familiar topic most of you know with standard quantum mechanics, and then it takes forward in creation and annihilation operator. It treats each mode of a field as an independent harmonic oscillator. That becomes easier. It also introduces Lagrangian formalism, so that from here the Euler-Lagrange equations apply to the Lagrangian, and it becomes easier for you to learn. Also, you will see that it introduces interactions via Feynman diagrams, so the mathematical derivations are not so intense, and that much portion is shown only that which is needed. So overall, I can tell you that Lancaster and Blundell's book is simpler because it explains complex concepts using familiar analogies. What are those familiar analogies? Harmonic oscillator, generalization, Lagrangian formalism, Euler-Lagrange equation, and that makes the a journey of QFT much more approachable without overwhelming the reader. That means, putting in a lot of difficult mathematics. So if I take at one left hand side the QFT by Professor Klauber, and if I take the QFT by Professor Lancaster and Blundell, what we can find is that quantum field theory, this book is rigorous, builds strong technical foundation. This book is much more intuitive because it talks about the Lagrangian part, which is easier to grasp. This is more of a step-by-step rigorous mathematics. Here you get a better and a mathematical physical intuition before going in the maths. Here the canonical quantization approach is taken care. Here it starts from harmonic oscillator and moves into the Lagrangian formalism, which becomes easier for students to understand. Now these are the 2 books. Be careful which one you are selecting, depend on your knowledge of how much mathematics you know. Now I will come to the magical book, which is the subject of today's video, and the name of the book is Quantum Field Theory as Simply as Possible, written by Professor Anthony Z. This is the cover of the book, which is there in Amazon. This is the Amazon ratings, and here you can see all the people I think which I have written, I have read from India. Good, extraordinary, excellent introduction, very readable, extraordinary book. All of the reviews are great, but I really wonder why only 69% people have given 5 star. I don't know how the rating has been done. Now I will go a deep inside and tell you why this is a magical book and why this is important. Now first I will start with the preface, where the author talks about what is quantum field theory. He gives you an idea of the origin of the book. The Professor Z also reflects on struggling with poorly written quantum field theory and as a student, and wishes a clearer, more insightful book. He recommends reading a book twice for a deeper understanding. Definitely it is true, for especially in complex subjects like QFT, and many readers of the author's popular books are professional from various fields. I mean to say scientists, doctors, lawyers, some retired, bravely tackling advanced physics topics. So it is expected that those who are not coming purely from the scientific background, Professor Z has made their life pretty easier and simpler. Now we move to the prologue part, and in this way he has arranged the book. The first portion is the prologue. In the prologue, he mentions the greatest monument and a roadmap for quest. Remember, this is just a guideline. In the prologue, he talks about how the book will flow in future. So first of all, he describes why quantum field theory is the most accurate. He gives exact measurements of the electron's magnetic moment. And then Professor Z talks about the arrangement he will take from Galileo to Newton and Einstein. Then he talks about the uncertainty principle. The book further talks about the famous Bohr-Einstein debate, the vacuum fluctuations in quantum field theory. And this portion actually attracted me very much. I've given a snapshot of this on my personal Facebook. The marriage of quantum mechanics and special relativity led to quantum field theory. I am surprised that this portion I have talked many times in my videos on quantum field theory, and surprisingly Professor Z also talks exactly the same words. So I was thrilled to find that my thoughts are actually flowing with Professor Z's thought. So here he talks about how the marriage of special relativity and quantum field theory, quantum mechanics led to the formation of quantum field theory. We move on the core part of the book, where this part, our physical world, professor has divided in different parts. 1.1, he talks about matter and the forces that move. Here he talks about the 4 fundamental forces: electromagnetism, strong, weak, and nuclear forces. And he discusses about the problems that why gravity is not fitting. He talks about the strong force which tries to hold protons together, but the electric repulsion between protons has a slight edge. He talks about the gravity and electromagnetism which falls up about 1 upon r squared distance. And he also tells that this balance explains why nuclear fusion powers stars steadily, while nuclear fission can release huge energy. So here a clear distinction between nuclear fusion and nuclear fission. This is important, quite fundamental before we move in quantum field theory. Next he moves into the same chapter 1.2, where he talks about the rise of the classical field. Here he talks about Newtonian physics, how the fields evolves, Faraday's and Maxwell equation, wave mechanics and wave packets. Further, 1.3, he talks about the time unified with space. Definitely it is important. Galilean relativity, special relativity and Lorentz transformation, and how Einstein united space and time in a space-time diagram. So remember, we are talking about QFT, where gravity is not taken into account, so he restricts himself only upon unified version of time and space in terms of special relativity. Further, in the section 1.4, professor talks about the concept of invariance, how things develop from 3 vectors to 4 vectors. Einsteinian relativistic mechanics is intrinsically simpler than Newtonian mechanics because it treats space and time as well as energy and momentum on an equal footing. I was really thrilled when I read through this book about this claim of Professor Z, that he tells that even Einsteinian mechanics is simpler because here really we don't have to take space and time as different coordinates, energy and momentum as separate, but rather united in one single framework. This is really a revolutionary, I would say, way of thinking QFT. Then he talks about Maxwell's equation. Further he goes in what is called the rise and fall and rise of particles, where he describes about the discovery of electrons, continuous, uncertainty principle, and the birth of quantum mechanics. So as you can see that this book actually gives you a clearer idea not only on the concept. Professor Z takes out through a fascinating journey a historical account which is very important in our learning. Then at the end of every chapter, he does a recap. So recap of part 1, recap of part 2, and so on. We move to part 2, where he lays the foundation of the road of quantum field theory. He talks about the principle of least action, the Lagrangian mechanics, and he discusses in details about action principle, which is very important in terms of QFT. Part 2 talks about the global versus local, where he talks about potential energy, simplifies physics, and so on. I am not iterating those things. You can pause and watch, make a note of this video. This part is where the quantum field theory actually kicks in. Now in part 2.3, here he enters the quantum world, where he discusses the simple things, probabilistic nature of quantum physics, and most importantly, you will find a section where he talks about complex numbers. Why? Because quantum physics depends on complex numbers. So those people who are lawyers and doctors and those who don't know about complex number, this book would give them a comprehensive understanding about complex numbers, and that would make them an easier understanding of quantum mechanics. He talks about a comparison of classical physics, quantum and classical physics, probability, amplitude, and so on. Again, he goes on recapping part 3, which is very important. Now till now, as you can see, the mathematics has been very easy. The language is friendly, giving you a historical account, and Professor Z has given a complete overview of whatever the background material which is required in order to understand the very complex quantum field theory. Now we get in part 3. In part 3, he discusses more about these parts. This is very important. We get into at the core of quantum field theory. He tells that why particles are excitations or disturbance on fields. If you watch my videos, I have also talked about this. He uses this mattress analogy. I hope you know how a mattress is arranged. The springs are attached at the corners. So pushing and pulling as a field creates waves that behave like particles. Further, he describes about the sinks. He shows that how photons and other particles are really just patterns of motions in fields, and highlights real world applications like antennas and detectors, how they are actually made from QFT. So part 3, as we move in quantum field theory, Professor Z gives an absolutely great idea how these abstract ideas of QFT can connect to the observable phenomena. We move to part 4, where he talks mostly about how Dirac treated electrons as quantum fields. He introduces Feynman diagrams, reinforces again that particles are not particles, they are excitations of fields, highlights role of conservation laws, which is very important in QFT, and he also tells that graviton, the elusive particle, still remains undiscovered, a quest for a theory of everything. So this portion overall talks about the fundamentals concepts of QFT, and it does that with clarity and intuitive visuals. In part 5 of this book, what we find is that how antiparticles arises, and these are not some ghost particles, these arises from Dirac's equation. He shows that how special relativity affects time ordering, antimatter is a fundamental consequence of physics. He also talks beautifully about the interplay of charge conservation, space-time, and quantum theory in predicting particles. So overall, this part he makes the origin and significance of antimatter intuitive and gives a very simpler understanding of what are called the fundamental laws, how they are connected. Part 6, the final part, where he talks a lot about the heart of quantum field theory. Here he talks about particles and identities. So he explains quantum particles are indistinguishable unlike classical objects. He talks about helium-3 and helium-4 to show particles follow probability amplitudes, and I was really smiling in my own mind, thinking about how he cleverly uses metaphors like social distance between electrons and partying bosons. You will really enjoy this part of the humor of the book. It is absolutely great. Intuitive analogies to make the concepts a little bit easier and accessible. He also talks about Bohr's atomic model and quantum jumps, and he explains the Pauli exclusion principle, showing how fermions occupy separate states while boson can share states. So he moves further in from quantum mechanics. He moves into quantum field theory, giving certain deeper explanations. Part 6 continues with a little bit deeper understanding towards unified theory, the grand unified theory, in search of a grand unified theory, etc. So overall, I can tell you that this book is intellectually rigorous but very engaging. I can tell you, you won't be able to give up this book once you start reading. The book balances historical concept along with the conceptual clarity, and there are a lot of intuitive analogies which makes the mathematics and the theory far more accessible. Now, if I talk of Professor Z's earlier book, Quantum Field Theory in a Nutshell, the second edition, which I have given a brief review in my earlier video, I consider this book, Quantum Field Theory, far better. And the reasons are in front of you, because this book is much simpler. It uses plain language, avoids jargons. It introduces all the concepts step by step, introduces historical concept so that we can really understand. There are a lot of intuitive analogies which makes things like mattress model, and you can actually imagine those abstract concepts in your mind, and you can feel how quantum field theory is relatable to real life. The minimal mathematics is used, starting from special relativity, Lorentz boost, etc. So you really don't have to be a mathematic wizard or a guru of mathematics in order to delve in this subject. It focuses on the key concepts and it uses Feynman diagram, and there are a lot of visuals with a minimum amount of algebra, which makes the book even more interesting. And finally, I would say it is written in terms of such beautiful historical concepts, clear explanations, that makes the book, I think, till now I have read one of the best book in quantum field theory. So this is perfect for learners who wants to have a strong concept of grasp for QFT, does not have a too much difficult understanding of mathematics, yet you can go into antimatter, matter, Dirac spinner, etc. So this actually bridges the classical intuition of quantum mechanics and the modern particle physics in a nice way, and I would rate this book 9.7 out of 10. I won't wonder that if you give 10 out of 10 of this book. It is just an amazing read. A strong recommendation to go ahead and read this book. So that's all for today's video. Thank you for watching this video. If you like, please do subscribe to my channel, Physics for Students, and keep this bell icon ringing so that you get all the notification from Physics for Students. You can follow me on my social media handles and write to my this email ID. Physics for Students will be soon back with more wonderful and fun-loving videos. See you soon in the next video. But till then, may the good Lord be with you.